All right, question 5, year 2018. Okay, so you are given this one adjacency matrix and also one graphs here. Okay, so yeah, they are representing different things. So to make sure that you go through a question properly. So adjacency matrix is the one that represented for town 1, then town 2 is represented in graph 2. Okay, so that's why they represent different things, just to make sure that you read that. Okay, so for part A, consider the adjacency matrix for town 1. Explain why the network represented by this graph is a directed graph. Okay, so same thing every time, no matter in what situation you want to check if an adjacency matrix tell you that your graph is a directed or undirected, then you will check whether it's symmetrical about the leading diagonal or not. Okay, so you can see that in this case, like these two numbers, they are different. These two numbers, they are different as well. So that's why in this case, they are not symmetrical about the leading diagonal. Then that's how you know that it's a directed graph. Okay, so that's why we will write down. Okay, the adjacency matrix. Okay, it's not symmetrical about the leading diagonal. All right, so you give a valid reason here, then you get your 1 mark. Okay, so just be careful that, for this kind of question, sometimes you can see that previously in one of the question, right? Or symmetrical about leading diagonal, they give like 2 mark, 1 mark for symmetrical, then 1 mark for leading diagonal. But for this question, they only give 1 mark for stating not symmetrical about the leading diagonal. So that's why you must remember, the word properly, like the leading diagonal. Because if let's say you only remember like symmetrical in this case, then you won't get any mark. Okay. All right. So give 2 reasons why the network represented by this graph is not a simple graph. Okay. So in this case, because we already talked about why is it a directed graph already, so now we are not going to look at the part that is symmetrical anymore. So when we talk about whether or not a graph is a simple graph, we talk about there's no multiple edges, there's no loop, right? For simple graph. So that's why when you try to look at this, so the first thing to check loop, you check the leading diagonal. Okay, so because leading diagonal give you the way that you can travel from A to A, from B to B, from C to C, from D to D. So that's why if let's say that is all 0 in your leading diagonal, it means that there's no loop. So now you can see that this number here is 1. So which means that there is one way that you can move from you can move from C to C. So that's why in this case, then you know that it is not a simple graph. Okay, so we try to talk about the first one. Okay, so we will say that that is a loop. Okay, so there's a loop at C, or you can say that there's a loop that joining C for C. Okay, joining C to C. So that's the first one. So then after that, second one, for multiple edges, then you check all the output, all the entry. So which means that you can see this, you can see this, you can see 2 here as well, and you can see 2 here as well. So in this case, it means that all these are multiple edges, because which means that there are 2 ways that you can travel from A to C. There are 2 ways that you can travel from B to C. There are 2 ways that you can travel from C to A, and there are 2 ways also you can move from D to C. So this is why you know that it is multiple, there are multiple edges here. Okay, so multiple edges. Sorry, I don't know why my pen today is like a bit, like when I'm writing, it's a bit funny. Okay, all right, so multiple edges between A and C. Okay, B and C. All right, where else? Then we have C to A. We should write 2 because this is directed graph. So multiple edges from A to C. Okay, then after that from B to C. All right, then after that from C to A. Okay, and also D to C. So that's this question. Okay, so two reasons. So the first one is talking about a loop at C. Then after that, you have the multiple edges at the different location here. So B, consider the graph shown in town 2. The adjacency matrix for town 2 has been square and is shown below. Okay, so you must see this word square. So that's why this is actually a M square matrix. Okay, so this question asks, explain the significance of the element in row 3, column 4. So that's why row 3 is here, column 4 is here. So it is referring to this number 3. So explain the significance, meaning that what is 3 here mean? Okay, then you are going to tell, because you know that this is M square. So M square shows you all the walks of length 2. Okay, and from where to where? This is from C to D. Okay, so that's why it shows that there are there are 3 walks of length 2, from C to D. Okay, so successfully know that you are looking at the number 3 here. You get 1 mark. Then after that, it states that the walks of length 2 from C to D, then you get 1 mark. So draw a connected subgraph containing only vertices A, C, and D. Okay, so for this question, then you try to look at, so A, C, and D, meaning that you can either draw a triangle. Okay, you can have all the different answer here, not necessarily the same as mine. So make sure that every time when you are drawing your subgraph, right, make sure that you are still able to see the original shape, which means that you can see that ACD is in, like, ACD is like this. Then you don't do it like change this become A, this becomes C, this one is D. So make sure that every time when you are doing your subgraph, you are still able to see your shape like quite properly. Okay, so this case, we have A here. Then after that, we have C here. Then we have D here. Okay, so make sure that you show your vertices properly, or even you can try to do things like this. Okay, so which means you only show your, let's say this is C, then this is A, and also this is D. Okay, so any diagram that is actually a subgraph, even you try to draw these two part also no problem. Okay, oops, sorry for that. So even you try to draw these two part also no problem. Okay, so as long as it's part of the graph without adding any edges, all right, that which means that you are still able to see that it is part of your graph. So able to get like a subgraph, then you get your 1 mark. Then after that, it includes, a subgraph that containing ACD, you get 1 mark. Then after that, the graph that without adding any edges, then you get 1 mark. So which means it's a proper subgraph lah. Okay, C, the local council of town 2 wants to add 1 extra route so that an Eulerian trail is possible. So draw an edge on the graph below that allow this to occur. So for Eulerian trail, then you need to have all even vertices, right? So which means that what you need to do is you only need to check the one that give you odd vertices. Then after that, you connect to another one that give you odd vertices. Normally, that will be a situation. So that's why you can see that in this case, C is the one that having degree of 5. Then after that, B is the one that giving you degree of 3. Other than that, they are all even. So that's why to make these two even, then you just connect them together. So that's why I need 1 more edge here. Okay, so successfully identify where is the edge to add, then you get 1 mark. So explain why an Eulerian trail is now possible. So basically, you know that Eulerian trail is possible when you have all even vertices. Okay, so that's why as now. Okay, so it contains all even vertices. Okay, so you successfully justify and give your answer, then you are able to get your 1 mark here. Okay, so that's it for this question.